All right, well, hello everyone. Got some fun stuff coming up. We have some proofs on our next test. There's some practice proofs on this assignment. There will be at least one or two proofs where it's just completely fill in the blank. And there will also be a proof where you have to figure out what goes in certain blanks. So we're going to go over both these proofs, and we're going to do the whole thing here. But I suspect the proofs are the hardest parts for most people. So let's make sure that we can do that. All right, so as with any of these proofs, guys, read the given, mark up the given. Can't stress that enough. These lines are parallel. There's really not much to mark up, but MC and HR, I'm going to highlight them so I can remember which lines are actually parallel. So those are my parallel lines. It then tells us A is the midpoint of HC. So here's A, and they're saying it's the midpoint of this line. I've seen some people put the wrong, I've seen people tell me those parts are equal. No. A is the midpoint of HC. That means that this half and that half must be equal. Now, the thing about a proof is when we mark it, we then have to write about it. So we have all the given stuff. I am not going to rewrite that, but all of that would go here. This, of course, is going to be given. And we need to say that HA is congruent to AC. And that is just definition of midpoint. Now, this is on Schoology, so you do have to pick from the selections, but I am certain that's going to be here. What numbers will those be? HA is AC, that is option number 7. Definition of midpoint is option number 17. All right, doing great. And then we're trying to eventually prove that A is the midpoint of RM, so, sometimes knowing where you're going, we're going to be using the line RM. Well, what triangles would that make? Yeah, I hope you can see it, but triangles 1 and 2, these are the triangles we're trying to make. So there's a few things that we could do. Honestly, we need to look at the options given, but I'm going to show you things that we could do. We could call this, let me erase that 1 and 2. We could call this angle 1 and angle 2. Those would be equal because they're vertical. And if this was a test or a quiz, you could do it any way you want. Because it's Schoology, we're going to have to follow their lead. So angles 1 and 2. If I call this 3 and 4, they're going to be equal. If I give you parallel lines, you need to be able to look out. There's two main things. The letter Z, like these two make the letter Z, start on red, end on red. Those are going to be equal because they're alternate interior angles. Or the letter F, which we don't really have here, but the letter F would be corresponding angles. So those are the two main congruent angles you're going to be looking for. And if I go over here, these two angles, those are also going to be equal. So we have lots of choices. We need to go look at the answer choices to see what angles they used. So I'm just looking through these answer choices. I'm looking for angles that they mentioned. Those are the big ones. I need to know what angles I'm allowed to talk about. Here's R and M. Are there any? Oh, here's a big list of angles here. So this is actually the one, I think. Let's go look at angle R and angle M. Oh, yeah, angle R. There's lots of angle. No, that's a totally useless one. There's 1, 2, 3 angle R's. There's 1, 2, 3 angle M's. That's totally useless for sure. So we know it's not that. That can't be it. This is the only other one I see that really mentions angles. These are triangles. Don't confuse that. So let's go see. Angle H and angle C. Would that be good? Yeah, this is angle H. This is angle C. That's a good one. And then what is the other one? HRA. Angle HRA. That's this one. And I'm hoping it goes with CMA. Yep, angle CMA, that's this one. So there we go. That's what we want. So we're going to get that in our proof. That would be angle H is congruent to angle C, which because there's only one angle H, you are allowed to say angle H. And angle HRA is congruent to angle CMA. Now, I call those angles 3 and 4, and on your test, you can just call them 3 and 4, but I'm writing it out because that's the way they have it. And I know my handwriting is pretty rough. I'm sorry. Let me make the end a little bit smaller. Angle CMA. All right. And that would be option number 10 there. And what was that reason? Well, it's based off these parallel lines. Those are alternate interior angles. So those are going to be alternate interior angles, and that's got to be a reason. If alternate interior, then congruent. No, That's not what it is. If lines are parallel, then alternate interior. Yeah, that's the one. That's the one. That's option number 3. All right, so we have a lot to go on. Can we actually prove these triangles are congruent now? Yeah, we have angle, angle, non-included side. So we can now say that these triangles are congruent. So what triangles are those? Those are triangles HRA. So that's going to look like it's going to be this one. That is triangle HRA is congruent to triangle CMA. And we just said that is angle, angle, non-included side. Okay, so we proved some triangles congruent. What do we actually need from them? We need to say that A is the midpoint of RM. Well, let's flip the script. What if I said, hey guys, A is the midpoint of RM? What would you know? If A was the midpoint, wouldn't these two be equal to each other? So if we're trying to prove it is the midpoint, we need to say that those two things are equal. RA is congruent to AM. So is that an option in here? Yeah, here we go. RA is congruent to AM. Oops. And that is from these triangles. RA and AM are corresponding parts. Those CPCTC. CPCTC. Woo! And now, would we know that A is the midpoint of RM? Yes. And even if you didn't know anything else, you would know that has to be the last statement. We would now know A is the midpoint of RM. And that is just definition of midpoint. Got it. Good work. Find those things. Moving along. All right, this one is more like a lot of it's filled in, but some of it's not. This is one we did in class, actually, where the entire left side was blank, which made it a lot harder. When there's left and rights, this is not as hard, but it's not going to be easy either. So let's pay attention to what we have. We have WS is congruent to YS. And there's no good way to mark that, but it's those two big sides. And then WC, that's this guy, and BY, that's this guy. And these get a little messy. We got to stay focused. All right, and then they said that SWY, that's this corner, SWY and SYW are congruent. Those two corners are congruent. And we talked about this. This big triangle is isosceles. So if I told you these two sides were equal, wouldn't that mean these two corners are equal? Yes, and that's basically what they're saying here. So that is just isosceles triangle, or definition of isosceles triangle. Got it. All right, and then they said reflexive property. Well, this is where it gets kind of tricky. What are they building? Like, where are we even going? So if we look at the next line, this is what we're trying to build. So I'm going to highlight those triangles, CWY, and its friend over here, I'll make green, BWY. They both use the side WY. So if these are the triangles we're trying to build, then what would be reflexive for those two triangles? It's going to be this side down here, WY. Okay, and now it can help to draw it off to the side. If I take this green triangle and draw it off to the side, we have the right side BY that was in the given. We have the bottom angle that was from the isosceles triangle. And then we have the bottom side that was our reflexive side. We now know that those two triangles are congruent because of two sides and the included angle, SAS. And then they followed up with the CPCTC. This will be a really hard follow-up to know which parts they use. There's a lot of options in here. So let's try our best to figure out what parts they used by moving on. Let's try the next thing, cow and boy, angle cow and angle boy. I'm going to erase some of this because there's a lot going on. So now they said angle cow, C-O-W, that's this angle, and angle boy, that's this angle. They said those are congruent. Okay, I can do that. That's vertical angles. That's just definition of vertical angles. And then they have some triangles for AAS. Well, what triangles could they be making? Well, if I trace that angle, this can be helpful, and I trace its friend, do you see these two triangles use that? Like, this is really all we could do. These are the only two triangles that look the same that use those vertical angles. So it's got to be the two blue triangles. It's got to. And they're saying that the reason is AAS. So let's think about what parts could we use from these triangles to build the new triangles. And it can help to highlight. If I highlight that old triangle, CWY, look at this pink triangle here. What do they have in common with the blue? What CPCTC would help us? This is very hard. I understand that. Well, they both use this side, but we've already marked that side. That was in the given. So yes, true, but not helpful. Is there anything else that they have in common? And they do. They have this angle at the top in common. Both blue and pink use this angle C. Now, one of the mistakes people make is they say that they both use W. Now, look really hard. The pink angle W is all of this, and the blue angle W is just that. So while they both have W in the name, there are three angle W's in the picture, right? 1, 2, whole thing, 3. Well, we don't want to do angle W. Like, they're different angle W's, but they're the same angle C. So that angle at the top would be the reflexive piece that we're looking for. So, not reflexive piece, the CPCTC that we're looking for. So if we go look at the options down here, it's got to be that angle C and that angle B. So angle WCY is congruent to angle YBW. That's got to be our option. And that is CPCTC. And now that we know that this angle is congruent to this angle, it can help to draw it off to the side. Like if I draw that blue triangle, we have the vertical angle, we have the angle at the top, and we have this side over here. That is angle, non-included side, which is what they said. They said angle, non-included side. So what triangles are those? Those are triangles cow and boy. So, I want to be a cowboy. So this is triangle cow is congruent to triangle boy. And that is angle, side. And then lastly, once you have congruent triangles, what's going to be the follow-up really often? COBO, COBO, that is CPCTC. 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 That's a tough proof, guys. There's just no way around it. That's a tough one. I don't think what you have to do on the test is quite that hard, just for the record. But it doesn't mean what's on the test is easy. That's a hard problem to do. All right, I think the rest of these won't feel as tough. You tell me. So hopefully we're getting better at this stuff. All right, this one says that BD bisects angle ABC. So we're not writing a proof, but I just need to mark it. Those two angles would have to be equal. And what values of, I need to fix that, but values of X would make the two triangles congruent? Well, they have a shared side. They have this angle. So if these two sides, if they were equal, then the triangles would be congruent. So I need to set those two sides equal. X squared plus 3x needs to be equal to 9x minus 8. If they were equal, we would have side included angle. That we would have side angle side. This is a quadratic, so we've practiced this. This was on the test. This was on the quiz. It's going to be on the test. We have to be able to factor. We have to be able to solve. First move is to clean it up. Well, it's already cleaned up. Second move is to make it equal to 0. So to make it equal to 0, I need to subtract 9x to the left. That would give me minus 6x and add 8. And if I did that, those things would go away. I want one side equal to 0. After that, I hope we're getting better at this. I hope you're doing it the way I've been teaching it. You read it backwards. What factors of C add or subtract to equal B? On this one, it's what factors of 8 add, that's add, it's a plus sign, to equal 6. What factors of 8 add to equal 6? 4 and 2. And it's negative 6. How do I get negative 6 out of 4 and 2? They need to both be negative. And then we need to solve it. What would make this equal to 0? X minus 4 equals 0. What is the answer? X would be 4. X minus 2 equal to 0. What would be the answer? X equals 2. So if it was algebra, we would be done. But it's not. It's geometry. We do have to plug them in and test. So we plug in 4. 9 times 4 minus 8. That would be 36 minus 8. That would be 28. And if we really want to check our work, plug it in up here. 4 squared plus 3 times 4. That would be 16 plus 12. That is 28. So we know we got the right number. 28 is a reasonable number. So we are in good shape. 4 is one potential answer. Then we need to try 2. Same thing. 9 times 2. Minus 8 would be 18 minus 8. That would be 10. That's reasonable. To check our work, we're going to plug it in up here as well. So this would be 2 squared plus 3 times 2. That would be 4 plus 6, which is also 10. If they're the same, we know we got it. If they're not the same, we messed up somewhere. But those are also reasonable answers. Could a side length be 10? Yes, a side length could be 10. So 4 and 2 both work. Both of those values of x would make that situation congruent. Those two triangles congruent. All right, triangle Q, Q-U-E, Q. So I'm going to draw that out. Triangle Q. So Q-U-E has an exterior angle at E. So I'm going to move that E down here. I'm going to draw an exterior angle at E. Q is 4 times bigger than U. So this is from Algebra 1. If Q is 4 times bigger than U, then U is kind of like our baseline. If I call U X, Q is 4 times that amount. It would be 4X. So if I call U X, Q would be 4X in that situation. It is 4 times that amount. The exterior angle at E, so this angle, is 20 less than, that would be minus 20, 6 times U. Well, what did we call U? We called U X. So it'd be 6 times X, 6 times U minus 20. So this would be 6X minus 20. So what we have here is our remote plus remote situation. R plus R equals E. That's a property you need to keep in mind. 4x plus x equals 6x minus 20. R plus R equals E. So 5x equals 6x minus 20. So x equals positive 20. So this angle would be 20. This angle would be 80. And then 6 times 20, that'd be 120 minus 20. This angle would be 100. Okay. Classify triangle Q by its sides and angles. Well, if that's 80 and that's 20, that's 100. This corner would have to be 80. So if two angles are 80 and the third one is 20, that is an isosceles triangle. Two equal angles means that we have two equal sides. In this particular case, this would be the vertex angle. These two sides would be the legs. So we know all this now. And it is classify it by its angles. You name the triangle by its biggest angle. Well, its biggest angle is 80. And 80 is acute. Remember, every triangle has two acute angles, so we always name it by the third angle, the biggest angle. And then the exterior angle at U. How big is I'm running out of room here, but if I draw the exterior angle at U, how big is that angle? Well, that would be a linear pair. That would be 160. Got it. Love it. Given, so if we have a given statement like this, what do we know? We know DA is congruent to BC, CPCTC. We know DC and BA, CPCTC. We know angle D and angle B, CPCTC. We know all of their parts are congruent. And often the picture is there to mess you up. All right, it says, how big is angle B? That's this guy. And what is B the same as? D. How do I know that? D and B are in the same spot. So we know those are equal, so we can take those two things and set them equal to each other. 2x squared plus 7 has to equal x squared minus 8x. First step, if it's a quadratic, is clean it up. Well, it's already cleaned up. And then make one side 0. So subtract x squared. 2x squared minus x squared would be 1x squared. Please don't write the 1. Add 8 would be plus 8x. And there's already a plus 7. So we subtracted that, we added that, and now there's nothing left over. What factors of 7? It's a plus again, so what factors of 7 add up to 8? Well, there's only one option, 7 and 1. Well, what do I have to do with 7 and 1 to get plus 8? I would need to do plus 7 plus 1. What would make that 0? X plus 1 equals 0. How would you solve that? You would have to plug in -1. What would make this one equal to 0? X plus 7 equals 0. You would have to plug in a -7. But we have to test our answers. So plug in -1 and see what happens. That would be +1. And then -8 times -1 would be +8. That would be 9. Could that angle be 9 degrees? Technically, yes. It doesn't look 9 degrees, but we don't care about that. To test our work, we can plug it in up here. That would be -1 squared would be +1 times 2 would be 2, and that is 9. So we know we got the right number, and yeah, 9 is a reasonable number. It's between 0 and 180. The other option would be -7. So -7 squared, minus 8 times -7, that would be +49 and +56. That would be 90 plus 15, that would be 105. Plug in over here to confirm. 2 times -7 squared plus 7. That would be 49 times 2 would be 96. Nope, 49 times 2 is 98 plus 7, and that would be 105 as well. Both are reasonable answers. We don't know which one it is, so we have to give both. And that's all we're doing there. Good deal. All right. It says given IH bisects angle WIS. If I trace that, that's WIS. That is this angle that's getting cut in half. That means that these two parts are the same size. That's all they gave us. But we also have a shared side here. So IH is congruent to IH. That would be reflexive. We're not writing a proof, though. So we have two angles and an included side. Just because there's a right angle does not mean it's HL. This is two angles and the included side. And then they said, what would line up? It says, finish the congruency statement. Triangle his, HIS, that was 91-S. Well, we got to do 91-. That's going to be HIW, 91-blank. So we got it. All right, next one. It says, which postulate proves the triangles are congruent? There's only two triangles in the picture. So let's see what we got. We have parallel lines. I find it helpful to highlight or bold parallel lines. So these lines are parallel. What a high quality picture. Look at this. So what do we know because of those parallel lines? That's a big deal, guys. Start on pink and turn. We would know angles 1 and 2. We would know that they are equal. So I'm going to mark those equal. Do we have anything else that we would know? Well, there's a shared side here. And then they marked those two sides. So we have side, included angle. So that would be SAS, side, included angle. And then it says, finish the congruency statements. Doop, doop. They said EGF. EGF. What would go with EGF? Well, if I put a 2- there, I'm going to go ahead and put a 2- here. And on this one, if that's a 2-, the 2- would go over here. So EGF is 2-, 1-, blank. So 2-, 1-, blank. would be HFG. Got it. All right. So we have a picture here. It says PR is congruent to PT. PR is congruent to PT. QT is congruent to QS. And angle Q is 30 degrees. Okay. So if I just look at this triangle, that is an isosceles triangle. Those two sides are equal. So 180 minus 30 would be 150. And I know that these two angles have to be equal. So 150 divided by 2, these would have to be 75 degrees. Just so you can see what I did 180 minus 30, gave me 150, and since they're equal, I divided that by 2. Then I have vertical angles, so these two are equal, making this one 75 degrees. And then this is also an isosceles triangle. These two sides are equal. So this is also 75 degrees. Those are the base angles over there. So we can actually get every angle in this picture. 75, this would have to be 30 as well. If those are 75, the one next to it would be 105, 105, 105, 105. And then we need this angle at the top. There's a few ways to get it. How many degrees are in a four-sided shape? That's 360. You don't even have to do that, though. Might be a little harder to see, but if I draw like this triangle, do you see the blue triangle? The blue triangle has corners of 105 and 30. So what would have to be left over? It would have to be 45 degrees. That's 135. What is 180 minus 135? It is 45. Or you could have done 360 minus 105, minus 105, minus 105. Either way, you could have got it. All right. Which descriptors do not apply to the triangle? Do not apply to the triangle. Select all that apply. Well, it's another isosceles triangle, so if that corner is 60, 180 minus 60 is 120. Divided by 2, these corners are also 60. So it's actually an equilateral triangle. So which ones do not apply? It is isosceles. It is equilateral. Remember, isosceles triangles can sometimes be equilateral, and this isosceles triangle is equilateral. So it's both of those. All the angles are less than 90. It is an acute triangle, and all the angles are equal. So it is equiangular. So the answer is, which ones are they not? Well, it's not scalene, it's not obtuse, and it's not right. That's not right. You gotta put it right. Let's see here. All right. Oh, she's actually in, Matilda. Okay. Chloe's favorite equilateral triangle is just too acute. It's just not right. The perimeter of Chloe's equilateral triangle is that. Yikes. If each side can be represented by that, what is the perimeter of the triangle? So they're saying one side is 3x and it's equilateral, so all sides are 3x. And then they said that this is the perimeter. So 3x plus 3x plus 3x has to equal 3x squared minus 9x minus 120. And that is a quadratic. So let's clean this up. This would be 9x equals 3x squared minus 9x minus 120. These 9x's do not cancel out. This is a positive 9x. That's a negative 9x. I need to subtract 9x from both sides. And I'm going to get 3x squared minus 18x minus 120. Now, this is not 1x squared. This is 3x squared. So be careful. But typically, this would be harder to factor. But what can we do to all three terms? We can divide them all by the number 3. So 3 divided by 3 would be 1x squared. 18 divided by 3 would be 6x. And then 120 divided by 3 would be 40. And it's what factors of 40 This one is subtract. What factors of 40? Subtract to equal 6. And that is going to be 10 and 4. 10 and 4 give you 6. Now, it's negative 6. So negative needs to be the overwhelming force. That means we need minus 10 plus 4. So what would be the solutions? What would make x minus 10 equal to 0? That would be positive 10. What about x minus 4? That would be negative 4. So we got to test those out. Let's plug them in. Well, if I plug in 10, this would be 30. All right, let me show my work. If I plug in 10, this would be 30. And if I want to test it out, I mean, that would make all of those 30. I could plug in 10 here. 3 times 10 squared minus 9 times 10 minus 120. That's 100 times 3. That's 300 minus 90 minus 120. 300 minus 120 would be 180. 180 minus 90 is 90. Well, what is 30 plus 30 plus 30? That's 90. So we know we got the right number. That could be it. The perimeter of the triangle could be 90. Let's try negative 4. Oh. What is 3 times negative 4? It is negative 12. That can't be it. So that one's out. And we could plug it in here as well. We would get negative 36 if we plugged it in over there. So it says, if only one answer is valid, type it in the first box. Type NA for not applicable to the second box. Like we don't need the second box. 90 is the answer, and there's only the one. Select the reason the triangles are congruent, or NEI if you can't tell. I think I can tell. There's a shared side. Side, included angle. Do we have the same thing over there? Yes, we do. So side, included angle would be side, angle, side. Nailed it. Here we have a shared side. That is side, non-included angle. Uh-oh. Does not work. So we would need more information. If we had another angle, we would be in good shape. If we had something else, but we don't have enough. If we had a right angle, I guess it would still be side, angle, side because we don't have the hypotenuse. But yeah, it's got to be NEI. Not enough. EH is perpendicular to YT. EH is perpendicular to YT. Ooh, that means we have a right angle here, which means this is a right angle. Those are going to be congruent. Those are perpendicular. Technically, they're all right angles, but we just care about the two inside the triangles. A is the midpoint of EH. So that means EA must be congruent to AH, right? It said A is the midpoint of EH. Make sure you're paying attention. That is not those two. It has nothing to do with the other line. YH is congruent to ET. So ET and YH, all right. What is the reason EAT is congruent to HE? Well, we have two sides and a non-included angle, but what's special about that angle? It's a right angle. So it looks like SSA, but since it's a right angle, it is HL. Let's go. The right angle is the key there. Perpendicular lines make right angles. Anytime you have a right angle, HL is a possibility. HL must be the hypotenuse and the leg, matching the hypotenuse and the leg. All right, given F. Well, I'm not going to give you an F. So let's calm down. Keep reading. F is the midpoint of AC. Here is AC. Maybe if you keep getting these wrong, maybe trace the line that they say, then put the midpoint on there. AC is the line that is cut in half. What is the reason AFE is congruent to CFG? So there's a lot going on in this picture. I'm going to go ahead and trace those triangles. This is AFE, and this is the other triangle, FGC. Well, they have vertical angles here, so I'm going to mark those. That's really all we got. Oh, well, we got, so if you see, like, look at this. There's just numbers there. If you see numbers, it's probably not by accident. If this corner is 80 and this entire corner is 100, what do we know about the lines? So if this is 100 degrees and this is 80 degrees, then these lines have to be parallel. So if those lines are parallel, if I start on, what is that, orange? Turn, I got to finish on orange, I would know this is 60 as well, or I would know that these two angles are congruent. So that would give me angle, non-included, or sorry, angle, included side. Angle, included side. Oh, that's hard. Yeah, so this corner's 80, this corner's 100, right? If I took out that extra line, if this is 80 and this is 100, then these two lines have to be parallel. Those are same side interior angles and they add up to 180. Same side interior angles need to be 180 if the lines are parallel. That's how we knew. So yes, we have parallel lines, even though they didn't directly tell us that. That's how we got those alternate interior angles. That's how we finished the job. Woo! Nice work, guys.